Hey, welcome back to the channel. Thank you for tuning in today. Have you ever wondered how the air temperature in an aircraft cabin is kept at a comfortable range for the passengers and for the crew in the aircraft, despite aircraft flying at high altitudes? As you all know, as the higher you go, the cooler it becomes. So beyond 20,000 feet, we have sub-zero temperature going up to negative 54 degrees centigrade. So how is the temperature in an aircraft cabin maintained at a comfortable range, say between 20 degrees to 27 degrees to 26 degrees? How is this achieved? In this video, we're going to be looking at the air conditioning system of an aircraft. For air conditioning system of an aircraft, we have two types of air conditioning system that are found on an aircraft. One is called a vapor cycle cooling system, and another one is called air cycle cooling system. We'll particularly focus on the vapor cycle cooling system in this video, and in our next video, we'll look at the air cycle cooling system. So the vapor cycle cooling system operates by cooling, by heating and cooling of a refrigerant, which is a very volatile liquid. In most vapor cycle cooling system, Freon 12 is a refrigerant that is used. Once it is exposed to heat that comes from the cabin, it evaporates into a gas. Then later it is exposed to cool temperatures, then it condenses back to liquid and the cycle starts again. This is how the cycle system operates. The refrigerant is changed from the liquid to gas, then from gas to liquid, then from liquid to gas, and from gas to liquid, as the cycle keep on repeating itself. We'll look at the major components that are found in a vapor cycle cooling system. And the components are as follows. We have 6 major components. We have the compressor, we have the condenser, we have the receiver dryer, we have the thermal expansion valve, we have the evaporator, and finally we have the refrigerant, which I've already mentioned. I will go through each component and explain a little bit some of the function of each and every component. So the compressor, you start with the compressor. The compressor pulls gas. Basically, it's a low pressure gas from the evaporator, and as the compressor pulls this gas, it compresses it. As it compresses this gas, the temperature of the gas rises, and the pressure and the temperature of the gas rises inside the compressor by the action of compression. From the compressor, this compressed and high pressure gas flows to the condenser. To the condenser, ram air that passes across the condenser cools this high pressure gas, and by cooling it, it condenses the high pressure to liquid. So in the condenser, condensation of the high pressure gas takes place, and what comes out of the condenser is a high pressure liquid due to the condensation that has taken place in the condenser. The high pressure liquid then goes to the receiver dryer. In this receiver dryer acts as a reservoir for the refrigerant, and it also acts as a component where the moisture that is found in the refrigerant is removed from the refrigerant, because this receiver dryer has a desiccant that acts to remove any moisture that is found in the refrigerant. From the receiver dryer, this high pressure liquid goes to the thermal expansion valve. The thermal expansion valve expansion takes place, and as you know, when expansion takes place, this liquid cools down, it further cools down, and as it cools down, also the pressure of the liquid reduces. So in the thermal expansion valve is where expansion takes place and cooling of the refrigerant takes place. So from the thermal expansion valve, we go through the evaporator. One more function of the thermal expansion valve is it regulates the amount of liquid that goes to the evaporator. So low pressure, low liquid comes from the thermal, low pressure liquid comes from the thermal expansion valve and goes to the evaporator. As it goes through the evaporator, the hot air or the temperature that comes from the cabin passes across the evaporator. So this heat, when it is exposed to the refrigerant that has come from the thermal expansion valve in the evaporator, the refrigerant gets, as it absorbs the heat, it evaporates. So this is where the cooling of the cabin takes place, because the heat that comes from the cabin is passed across the evaporator, and as the refrigerant inside the evaporator gets this heat that comes from the cabin, it evaporates into gas. And this gas goes back again from where we started the compressor. It goes next step to the compressor, where it is compressed, increasing heat and the pressure of the refrigerant. So those are how the components of a vapor cycle cooling system work. In this diagram, we'll show you, I'll go through the components. As you can see, we have the compressor here, we have our condenser, we have the receiver dryer, we have the thermal expansion valve, and we have the evaporator. Remember what I've said. Let's start from the compressor. This is where the gas is compressed. As it is compressed, the temperature and the pressure of the gas increases, then it goes to the condenser. Ram air that passes across the condenser cools the high pressure vapor. As it cools the high pressure vapor, the vapor condenses. As it condenses, it changes state from the gas or vapor to liquid. As it comes out, it's a high pressure liquid. It goes to the receiver dryer where moisture is removed from the liquid, and then it goes through the thermal expansion valve where it is expanded, cooling it further and reducing the pressure. And as it cools down, as the liquid cools down, the regulation of the amount of liquid that goes through the evaporator takes place. And then from the evaporator, the heat that comes from the cabin passes across the evaporator. And as it passes across the evaporator, the refrigerant turns from liquid to vapor, and the cycle continues again and again and again. So this is all we had for you in this video. In our next video, we'll be looking at an air cycle cooling system. Thank you for tuning in, and don't forget to subscribe if you haven't subscribed. Goodbye.